Hi everybody, I have one more video about half-angle formulas. This time we'll be using some information about the quadrant of a given angle and a trig value of alpha to find a trig value of alpha over 2. As a quick reminder, we have half-angle formulas for sine and cosine, and then we have 3 different versions of half-angle formulas for tangent. To start, we're going to use the half-angle formulas to find the exact value of sine alpha over 2, given that alpha over 2 is in quadrant 2 and cosine of alpha is 137 over 529. Our half-angle formula for sine is sine alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 2. We were given that alpha over 2 is in quadrant 2, and in quadrant 2 we know that sine is negative. That means we can use the formula sine alpha over 2 is negative the square root of 1 minus cosine of alpha over 2. We were also given that the cosine of alpha is 137 over 529. We plug that into our formula. In the numerator, I can write 1 as 529 over 529. Then I'll subtract 137 over 529. My new numerator is 392 over 529. I'm going to divide the 392 by 2, which gives me 196. Now I have negative the square root of 196 over 529. To finish the problem, I'll take the square root of 196 and I'll separately take the square root of 529. My final solution is negative 14 over 23. My second question says find cosine of u over 2 if the cosecant of u is 15.81 and u is in quadrant 2. I'm going to start out by thinking about u being in quadrant 2. Since u is in quadrant 2, I know the value of u is between 90 and 180. I am looking for the value of u over 2, so I'm going to divide 90u and 180 by 2. That tells me that u is between 45 and 90, which places u over 2 in the first quadrant. Because u over 2 is in quadrant 1, we know that cosine is positive. Let's use the formula cosine of alpha over 2 is equal to the square root of 1 plus cosine of alpha over 2. We'll need to find the value of cosine of u to be able to complete our problem. There are multiple ways to go about finding the cosine of u, but let me show you what I think to do this time.
Cosecant of u is 15.81.
That makes me think that 1 over sine of u is equal to 15.81. I can do a quick flip of the fractions to get that the sine of u is 1 over 15.81. I'm not going to put that in my calculator because it would give me a long decimal that I would have to round. I don't want to round until the last step of the problem. So instead, I'm going to bring back in our Pythagorean identity for sine and cosine. I'm going to look at sine squared u plus cosine squared u is equal to 1. Since I know the sine of u, I can put in that 1 over 15.81 squared plus the cosine squared of u is 1. I'm trying to solve for the cosine of u, so I'm going to move the 1 over 15.81 squared to the right side of the equation. Then I'll take the square root of both sides, and I'll put that in my calculator. At this point, I'll go ahead and round. I get 0.998. Notice I put a negative sign in front of our number. At the beginning of the problem, we said that we're in quadrant 2 where cosine is negative. So it's super important that you attach the negative sign to the numeric value. Now we're going to plug negative 0.998 into our cosine of alpha over 2 formula. We have the cosine of u over 2 is equal to the square root of 1 plus negative 0.998 over 2. Again, we grab our calculator, which tells us that the cosine of u over 2 is about 0.03. I wanted to add a quick note about calculators for these problems. Because we can't specify the quadrant of the angle, when you put values into the calculator cannot accurately find the values of the half angles for all the problems. You might get lucky and find a couple that work if you're in the first quadrant. But as we move from quadrant to quadrant, the calculator doesn't know when to insert negative signs into the formulas used to calculate the half angles. Because of that, you can get a misleading and inaccurate value if you rely on calculators to solve these types of problems.